All right, so this is going to be section 1.4. This is on continuity and one-sided limits. Very, very basic. This will not be a very long video at all. What we just want to talk about here is continuity, which we've actually kind of gotten into before. The three things that we want to look at is when continuity can be actually eliminated or destroyed is what we're going to call it here. And the first one, it says the function is not defined at x equals c. So this first one, f of c is not defined. You see a hole there. That means it's discontinuous. Remember, that doesn't necessarily mean that the limit doesn't exist. It just means that it's not continuous there. The second one is if the limit does not exist. So here, you see in the second graph, you have from the left side, you're going to one point. From the right side, you're going to another point. So the limit doesn't exist there, therefore it's also not continuous. So a function's not continuous if it's not defined at a point, if there's a hole. It's not continuous if the limit doesn't exist, if it's approaching two different points, basically a jump in the graph. And the last one, if the limit exists, but it's not equal to f of c. So in this case, you see that the limit exists there, right, just like over here, and then there's a point that is also defined. So that is still considered discontinuous because the point is defined somewhere else and the limit exists. So those three things are what determine continuity for the most part. Okay, we have definition of continuity. We just talked about this. If f of c is defined, if the limit exists, you can have, the conditions have to be met. Okay, and then also as the limit approaches, you get f of c. Now, keep in mind that even though these are true, if these are true, it doesn't necessarily mean that they, one of them can't be true. It has to be all three of them, okay? So that's pretty much the idea. We've gone through a lot of this. Basically we're going to be looking at problems and just determining whether they're continuous, and we're basically just going to be using these three ideas just to see if something is continuous at a specific point. Now, the other thing you have to keep in mind is that usually when we talk about continuity, we're talking about continuity at a specific point. So you see this at c. We're not saying whether a function is continuous all the way through. So for example, looking at these functions, if I asked you, is this function continuous at this point right here? Absolutely it is. Just because there's a hole somewhere on the graph doesn't mean that the whole thing is discontinuous. It's just discontinuous at that point. Just like the only place that it's discontinuous here is here, and then at these holes over here. Everywhere else on those lines, it's still continuous. Okay, so let's move on. What we're going to do is we're just going to discuss the continuity of each one of these functions. So it's important for us to be able to look at a function and know what the continuity is going to be. So in this case, and you can graph these if you really want to, but you shouldn't need to for some of these. So the first one is just a basic 1 over x. So the idea of this is we should be able to figure out what the continuity is going to be just by looking at the function. So I know that the bottom of a fraction cannot be 0. So what we could say here is we can say that at x equals 0, there's an asymptote. It's a non-removable discontinuity. So we have a non-removable discontinuity, which is also the same thing as an asymptote. Okay, so that's what we're discussing the continuity. At x equals 0, we have a non-removable discontinuity, and then we can also say that everywhere else it's continuous. I'm sorry about my writing, but okay, so we have a non-removable discontinuity at x equals 0. Everywhere else it's continuous. That's discussing the continuity. Okay, the next one, we have x squared minus 1 over x minus 1. So if you recall, we can factor the top to be x plus 1 and x minus 1. And then our x minus 1s will cancel out. So we can say x equals 1 is a removable discontinuity. The good thing is a lot of stuff in this section we've already covered before dealing with the removables and non-removables. And remember, removable is the same thing as a hole. Okay, so that means it's discontinuous there, and then we can say that it's continuous everywhere else. So when you're talking about a discontinuous function, we're just talking about where it's discontinuous, and basically that's it. We know that it's going to be continuous at a lot of places. We just have to determine where it may not be continuous. So in part C, these ones are a little bit more difficult, and this is something that we have to understand. So this right here, it determines when our function is defined. So basically what this function is saying is that our function will be x plus 1 when x is less than or equal to 0. So if we are looking on a coordinate plane, what that's saying is that if any value is less than or equal to 0, so going in that direction, this is what our function would be. And then anything to the right of 0 is going to be the bottom function. So really, I know that in and of itself, x plus 1 is always continuous. I also know that in and of itself, x squared plus 1 is always continuous. What we need to determine, however, is what's going to happen when they change over. What's going to happen at 0 with each of these functions. So what we're going to do is we're going to plug in 0 for each function to see what's going on. So this top one would be 0 plus 1 equals 1. The bottom one will be 0 plus 1, which is also equal to 1. What this means is that when our functions change over, when we change from the top function to the bottom function, they are both equal to 1, which means it is continuous at that point. Okay, so I'm going to write at x equals 0, this is where the function changes. Okay, so that's where the function changes from one to the other. So what we can say is because, and this is going to be a limit, and we're going to just define this by limits. Because the limit as x approaches 0 of h of x is just our function defined, because it equals 1. Remember, what this means is, it means the limit as x approaches 0. It means from the left and from the right. If it equals 1, that means the limits are the same from both sides. Okay, because those limits are equal to each other, we're going to say it's continuous everywhere. Let me scroll down a little bit here. So because the limit actually exists, our h of x is continuous everywhere. Again, I apologize for the writing. I'm zoomed in a little bit here, so it's a little bit harder to write. So the last one, y equals sine of x, again, all we're looking for is there anything that's discontinuous? And hopefully you understand that a sine of x is just a curve that never ends. So we're going to say that this is continuous everywhere, or at, we can say at all real numbers. And that's really all you're doing with the continuity, is trying to be able to determine when it's continuous and when it's not. Okay? So one-sided limits, we're going to do this very, very quickly. A one-sided limit is, you just need to make sure that you understand the notation. So see with that little plus, when it's denoted with a plus, it means the limit from the right. In other words, what is happening from the right-hand side. And then the limit on the with a negative means what's happening from the left-hand side. In other words, on these ones, we don't have to look at it from both sides. We only have to look at it from the right or the left. So this example right here is pretty clear. Here's the graph. It says, what is the limit as x approaches -2 from the right? In other words, we're only looking from the right to that point. So as it approaches -2, our limit is equal to 0. And that's all you have to do. Okay? And then the general rule is if the right-hand limit and the left-hand limit are both equal to the same value, then we know the limit exists. And that's usually how we're finding out if limits exist, is if the right-hand limit and the left-hand limit are equal to each other. So just make sure you understand the difference between a right-hand limit, a left-hand limit, and then what a regular limit is. That's what's important out of this. So that's all I have for you. I will see you in class. Don't forget to take your Edmodo quiz if that's been assigned.